This is the third and last video on inconsistent equations. This one is going to be an example of when there is no parallel planes. So this will be the third example, as you can see here, and this will be when the planes intersect each other but not at the same place. So blue will intersect red, but it will be away from where blue intersects green and red intersects green as well. So much like the last couple, there is going to be this sort of question: show why these equations are consistent, show what the planes would look like by determining a relationship between the three equations. So, like the last few times, label your equations and just pretend you are going to solve it as if you're going to find x, y, and z. So, at this point, I would probably look at it and go, well, I'm just going to try and eliminate x. Okay, I'm going to do it from b and a. So I'm going to do 3b minus 2 of a. Now, most people look at this and go, oh, why not just do it on b, so b add 3 amount of a and eliminate the y's. That's absolutely fine as well, but you would also need to do it for these ones as well. So I'm just going to go for the x's, just keep it consistent with the first one. If you don't want to do that, that's absolutely fine. So as I said, I'm going to go for 3 amount of b, subtract 2 amount of a. So I'm going to write in this 3 amount of b, that is 6x, that is 9y, and it is negative 21z. Remember, if you're stuck, please use your calculator. 3 6's are 18. So that is our equation for 3b. Our equation for 2a will be 2 amounts of 3x, which is 6x, 2 amounts of negative y, which is negative 2y, negative 10z, and 38. Now remember, I'm subtracting these, so gather these like that. And as we can see, the x is eliminated as we planned. However, none of the rest of the things have eliminated. That means we are probably going to end up with a straight line here. So 9y subtract negative 2y is positive 11y. And this one in here is negative 21z, subtract negative 10z is negative 11z. 18 subtract 38, that gives us negative 20. So that is our equation there. That tells us that the planes A and B, so the planes A and B intersect on this line. So we move on and we see, can we figure out if either A and C are parallel or B and C, one of the two. So I'm going to look at A and C, and I'm going to eliminate x again. So I've got 3x here, I've got 1x here, so I'm going to go for 3c. So 3 amounts of c, subtract a. So 3c, what would that look like? That would look like 3x minus 12y plus 6z equal to negative 21. What would a look like? Well, a is just literally what a is up there, 3x minus y minus 5z equal to 19. So at this point, I am now going to try and eliminate the x. So 3x subtract 3x. That's good. At this point, negative 12y subtract negative y. That gives me negative 11y. Remember, if you're stuck with that on your number line, negative 12 is down here, 0 is there. Subtracting a negative is up 1 is negative 11. So just in case that did not make any sense. Calculator is what you should use if you're really stuck. 6 subtract negative 5 again goes up the number line, that's positive 11z. Negative 21 subtract 19 takes you to negative 40. This bit here tells you that A and C intersect on this line. At this point, it is worth noting, if you have noticed, that this equation and this equation actually have the same coefficients of y and z. If I just take this and I change this to, so I've multiplied everything through by -1. So this is positive 11y, negative 11z, positive 40. The only things that are different are the constants. Now when I scroll up here, this is what this sort of thing here is talking about. The straight lines have their x, y and z coefficients in propulsion, but not their constants. Okay, so as you can see there, if I had done 11 divided by 11 for these two, negative 11 divided by negative 11, that would be the same. Similarly, if I tried it with eliminating the y variables, the x coefficients and z coefficients would be the same propulsion. So do keep that in mind when you're going forward. So as we proved that they are the same coefficients, that means that these two lines are parallel. So 11y minus 11z equals -20, and 11y minus 11z equals 40 are parallel. And that's lines, not planes, so those two lines are parallel. Basically, you could do the third thing just to prove, but you get the same thing again. You get some multiple of 11y minus 11z out, and with a different constant. So as A and B intersect, as A and C intersect, that means A and B are not parallel, A and C are not parallel, therefore B and C are not parallel. So none of the planes are parallel. They all intersect on different straight lines which are parallel. If you're not sure what that looks like at this point in the video, I'm really hoping to have something over here, hopefully showcasing that. So none of the planes are parallel, they all intersect on different straight lines which are parallel, so that's what it looks like. So the equations are inconsistent and there are no solutions because the three planes don't intersect at the same point. So at this point, hence there are no solutions. And the planes, the equations A, B and C are inconsistent. Hopefully you can see on this right hand side what it looks like. It should kind of look like this sort of thing from a side on view. So this is where two of them intersect, this is where two of them intersect, this is where two of them intersect, but not all in the same place. So that is it for, as we can see up the top, inconsistent equations. So we've done 3 videos, each for the 3 sort of outcomes.